Alrighty, these are the Unit 7, Section 3 notes. In this section, we're going to be talking about scientific notation. Scientific notation you may have seen before, or you may have used this before, especially in your science classes. So scientific notation are when numbers are written in the form of c times 10 to the power of n, and c must be between 1 and 10. So for example, a number written in scientific notation might be 7.25 times 10 to the 5th power. Scientific notation is really helpful because it allows us to write and use either super large numbers or super small numbers. And like I said before, you will frequently see this used in science, especially when looking at numbers in terms of space or astronomical data. Is where you will often see it. As in that case, you're using really, really big numbers or even small numbers. So let's talk about how to use it. So for example, our first number, we have 1800. That number is written in what we call standard form because it's just a regular number like we've seen before. So that is written in standard form. In order to write it in scientific notation, again, we want to get a number between 1 and 10. So the way we do that is we're going to start with 1800, and we're going to start where our decimal point is, which is here. And in order to get a number between 1 and 10, we're going to move that decimal 1, 2, 3 places. So we're left with 1.8 times 10 to the how many places did we move? To the 3rd power. And if we wanted to go the other way, we would say 1.8 times 10 to the 3rd. We would move our decimal 3 places to the right. 1, 2, 3. Again, that leaves us with 1800. If we have a super small number, such as number 2, we still do the same thing. However, we're moving our decimal the other way. So in this example, we're going to move our decimal 2 places to the right to get an answer of 2.4. And we're going to still multiply by 10. Because we're moving our decimal to the right, we're going to have a negative exponent. So that was going to be -2. And again, if we wanted to go back the other way, we would start with 2.4. We have a negative exponent, so we're not going to move to the right. We're going to move to the left. So 1, 2, fill in our zeros. And 0.024 is our answer there. Sorry, that's not written very neatly. There we go. All right. Number 3, 634,000. Again, we want a number between 1 and 10, so that's going to be 6.34. How we got there was moving our decimal 1, 2, 3, 4, 5 places, so times 10 to the 5th power. Number 4, we're going to go the other way. 1, 2, 3, 4 places, so 8.1 times 10 to the, you guessed it, -4. All right, so now we're going to look at going the other way, which is what I showed you in the first 2 examples, starting with a number written in scientific notation and going back to that standard form, numbers that we see and use all the time. So if we have 3.1 times 10 cubed, we're going to start with 3.1 and we're going to move our decimal 3 places to the right. So 1, 2, 3, fill in my zeros. My answer is 3,100 or 3,100. You can also check this and think that 10 cubed, you know, is 1,000. So 3.1 times 1,000 is simply 1, 2, 3, which leaves you the same number of 3,100. 5.2 times 10 to the -6. So again, we have a negative exponent, so we're going to move our decimal to the left, and we're going to move it 6 places. So 1, 2, 3, 4, 5, 6, and that should leave us 5 zeros. 1, 2, 3, 4, 5. That is our answer there. Number 3, we have 8.6 times 10 to the 5th power. Again, I'm going to move my decimal 5 places to the right. 1, 2, 3, 4, 5. Fill in my zeros. There should be 4 of them to get my answer of 860,000. I'm going to leave number 4 for you to try. Pay close attention to that -2. You have a negative exponent, so you're going to move your decimal to the left. All right, in the next section, we're going to talk about how to order numbers using scientific notation. And as always, we want to pay attention into how they want us to order them. And they're asking us to go from least to greatest. So our first number is written in standard form for us. So we have 3,200. Our second number, we have 3.3 times 10 to the third. So I'm going to move it 3 places, 1, 2, 3. That number is 3,300. Last but not least, I have 7.2 times 10 squared, so move it 2 places to the right, 1, 2. That leaves me an answer of 720. If I were to write these in order from least to greatest, I would have 720, 3,200, 3,300. Those are the numbers in standard form written in from least to greatest. So if I match those up with their scientific notation, that's 7.2 times 10 squared. 3,200 was already there, but we can write that also as 3.2 times 10 cubed, and this one would be 3.3 times 10 cubed. All right, number 2 works the exact same way. I'm going to leave that one for you to try. Again, you're ordering these in order from least to greatest. All right. We've got 2 more sections here. Oops, sorry, it's jumping all around there. There we go. All right, we're going to talk about how to multiply numbers in scientific notation. So as always, when it asks us to find the product, that does mean an answer to a multiplication problem. So the first thing I'm going to go ahead and do is I'm going to multiply 5 and 4 to get 20. If you notice, my base is the same here, and if you remember about your exponent rules, when you have the same base, you simply keep the base the same and add the exponents. So this would be 10 cubed. In order to write this as a number in scientific notation, however, we need a number between 1 and 10. So that would be 2 times 10 to the 4th. Both cases will give you the same answer. So let's double check that. We have 20, 1, 2, 3. That's 20,000. 2, 1, 2, 3, 4. That number is also 20,000, so they do match. All right, number 2, I'm going to multiply 1.6 and 4. And if you do that, you'll get an answer of 6.4. Then we have our same base again, so I'm going to add my exponents, times 10 to the -9th power. Because my answer is between 1 and 10, 6.4, that is already written in scientific notation, so we're good to go. All right. Our last section, we're going to talk about dividing numbers in scientific notation. So if you look in the first one, 4.6 is half of 9.2. So I'm going to go ahead and write that as 1/2. 10 to the 9th and 10 to the 6th, if we subtract those, we get 10 cubed, or 10 to the 3rd power. That could also be written as 0.5 times 10 cubed. Remember, though, in scientific notation, we need a number between 1 and 10. So if we change that, we would simply have 5 times 10 squared. And if we check that, 1, 2, 3, that equals 500, and 5 times 10 squared is 5 times 100, which simply equals 500. All right, number 2, if you divide 3.95 divided by 5, you will get an answer of 0.79. And when you subtract your exponents, -3 minus a -1, that leaves us with a -2 as our exponent. Again, we need a number between 1 and 10. And so that is going to be 7.9 times 10 to the -1. That would be our final answer. And if you notice, that does check. Those two do equal each other. Alrighty, so that concludes Unit 7, Section 3. Again, if you have any questions about exponents or the rules of exponents, negative exponents, or even scientific notation, please be sure and check in with your teacher.